Hello, my Algebra 2 students. This is day 2 of Unit 9, and we are focusing on simplifying rational expressions. So you are taking your own notes. Feel free to pause and grab some paper if you need to. Otherwise, we are going to start right off with remembering what it's like when the directions say to simplify a fraction. So as an easy example to work with, if I give you 18 twelfths, there's a couple ways that we can do this. One way to do it would simply be to say, okay, I can think about dividing each piece of it by a common factor, right? And so like I can divide by 6 and I could divide this guy by 6 and that would give me 3/2, which really is just factoring. And so if we said, okay, let's take 18 over 12, I can break that down into 6 times 3 and into 6 times 2. And then you can simplify out or divide out that common factor and be left with 3/2, right? Something that we are not allowed to do. And I know it sounds weird to mention it, but it's good to just kind of throw it out there now. Is what we are not allowed to do is break it up into added pieces and then simplify. So an example of what I mean is that I could write 18 as 10 plus 8, and I could write 12 as 10 plus 2. So if it's separated by an addition sign, I'm not allowed to say like, oh, hey, look, those cancel, and then be left with 8 over 2 and come out with 4. It makes complete sense when we're dealing with numbers, and you're probably all watching it thinking like, I wouldn't do that. But you'd be surprised that you'd try to do it if that had been an X and not a 10. All right. So just a little note to self that it's not the same answer. So breaking up into addition, nope. But breaking it into factored parts or multiplied parts, yes. Right. So what I want you to recognize from that is you can only cancel from numerator to denominator, there we go. When the expression is factored first. So you got to factor this guy first, then we can cancel or simplify out any common factors. All right. With that being said, let's hop on into a bunch of examples. That's our goal. Is just to have a bunch to pull from so that when we hit the homework, we'll have seen a little bit of everything. So the directions for each is going to be exactly this, to factor and then simplify. All right. I'm going to start with one where I think you'll be very comfortable. I'm going to give you x squared minus 9 divided by 2x plus 6. So factoring is a skill that we have definitely worked on this year. So when we think about factoring the top, we've got difference of perfect squares here. So x plus 3 times x minus 3. In the denominator, just a little GCF. And then once you have it into factored form, any common factor from top to bottom can be essentially divided out or simplified out. And then what we're left with is x minus 3 over 2. That's it. Nice and easy. All right. So as a little reminder, all the types of factoring. We just saw GCF and difference of squares, or difference of perfect squares, however you'd like to write it. Either one is totally fine. Okay. Other methods, we can do our whole add multiply, which is trinomial factoring. With that goes slip and slide, or whatever the heck we called it. Slip, slide, divide, something. All right, there's factoring by grouping. And then we also talked about sum and difference of cubes. So all of those types of factoring can present themselves here, and you want to be prepared for them. So with that being said, try number 2 here. Number 2 doesn't really require any of these. I know that sounds like a weird setup, but I also want you to think, okay, well, what if I don't have this? What's the only other thing you could see? So if I have 3x squared times y cubed over 6x to the 5th times y. Something to keep in mind, when I simply have a monomial here, so a single term and a monomial here, one thing that you can do is you can actually break it apart so that I look at this as 3, and then x squared is x times x. Y cubed means I have 1, 2, 3 y factors there. And then I could do the same thing in the denominator. The 6 I can break into 3 times 2. And then I would have 5 x's. So 1, 2, 3, 4, 5, and then a single y. So I bring that up because if you only have monomial terms and we can't figure out how to use this, then I can always then break it up and divide one part for one part. So meaning if I have a 3 in top and bottom, it goes. For each x, I can cancel. So those x's are going to go, and I have a single y that I can cancel from each. And then what I'm left with would be y squared up top. And then in the bottom, I have a 2, and then I have x cubed. So then 2x cubed would be my final answer right there. All right. Now, do you have to do it like that? No, but if it helps you, feel free. Otherwise, some quick little shortcuts to remember when we have something like what we just had a moment ago, like y cubed over plain old y. That's a y to the first. When you are dividing the bases, you can subtract the exponents. So this would be y to the 3 minus 1 or y to the second. And the general rule was that if you have like, let's stick with y to the m power over y to the n, then it's equal to y to the m minus n. The next unit we cover will actually talk about all these rules a little bit more in depth, but hopefully that's something that you remember from Algebra 1. Sorry, that looks a little funky right there. I can fix that up just so it's more readable. There we go. All right. Extending that rule is, what if the exponents go the other way around? So if I had y to the first divided by y cubed, I can still use the rule. It would be y to the 1 minus 3, which would be y to the negative second. We don't ever want to leave a negative in the answer, but that would be the same as if the y to the second was in the denominator, just like how it worked out with the x's up here. And so something to keep in mind, if I have a negative exponent, it means that you're going to flip it over and it'll end up in the denominator. Just write yourself a little note that we'll see more on this later. All right. Let's try another example where maybe we are using all those factoring methods that we just talked about a moment ago. So I think I have just enough space that I can squeeze one in here. All right, so example 3. Let me give you x to the second plus 5x minus 14, and then all over x squared minus 4. So when you think about the different factoring methods, well, this one's a trinomial. Here's a binomial. We've got a nice little add multiply here. So we can go x plus 7 and minus 2. On the bottom, x plus 2, x minus 2. And then our goal should always be to see a common factor. So when I divide these, remind yourself, you're leaving 1 in its place, because anything divided by itself leaves me with 1. And so then I'd be left with x plus 7 over x plus 2. Here's where you want to remind yourself that when it's split by a plus sign, I am not allowed to cancel those x's out, right? They either stay together, the whole thing, and the whole thing goes like it did here, or you're stuck with all of it. Mm-hmm. All right. Let me jump to a new page so I've got a little bit of space. Let me give you a chance to try one more with those monomials. So for number 4, you have 20 x to the 10th, y to the 8th, and then divided by 4x squared y to the 5th. Right? Because they're monomials, The whole difference of squares and all that stuff doesn't apply. What I would suggest is you can either write it out, which would be a little obnoxious, like writing out 10 x's and 8 y's, or take it one thing at a time. So deal with the numbers, deal with the x's, deal with the y's. If you can break it into 3 little problems, then it's pretty simple. So 20 divided by 4 should be 5. X to the 10th over x to the 2nd should be x to the 10 minus 2. And then for the y's, y to the 8th over y to the 5th, 8 minus 5. And so this is going to be 5x to the 8th, y to the 3rd power. So there's that rule again in action. All right. Let's go back to challenging some of those factoring skills. We've got 3x to the 2nd plus 14x plus 8 all over x squared minus 16. All right, I'm not trying to trick you. Everything here should be able to be factored. So in that numerator, this is where we would use a little slip and slide. So let's take that 3, multiply it over, and focus on that numerator for a moment. So that's going to give us x squared plus 14x and then plus 24. That, if we think about what adds to 14 and multiplies to 24, well, that would be 12 and 2. So if we go 12 and 2, remind yourself to finish the process. Divide by that leading term. Whoops, they're both going to be pluses there. This will give us x plus 4. This will give us 3x plus 2. All right, now whenever we did this earlier in the year, I made you multiply it out to double check. Even if you do a mental check it out. So if we, run through foiling in our head. So first gives me 3x squared. Outside is 2x. Inside is 12x for a total of 14. Last will give me that plus 8. All right, that's the numerator. Now bring the denominator down. That's a nice difference of squares. So x plus 4 times x minus 4. All right. Both have the x plus 4s. Those are going to go away. And we are left with 3x plus 2 and then over x minus 4. Awesome. All right. Number 6. This one here. Excuse me. If I give you 4x squared minus 1 and then over 4x minus 2. Think about what type of factoring. It's a binomial, perfect square, perfect square. This is difference of squares. We've got 2x plus 1 and 2x minus 1. In the denominator, don't forget, it's just a simple GCF. So if I take out a 2, I'll be left with 2x minus 1. And the nice thing is once you factor one part, it kind of helps you look for those common factors in the second piece. So this should then be 2x plus 1 all over 2. Technically, you could take this further. I would probably stop right there. But if you wanted to, you could take 2x over 2 and take 1 over 2 and leave this as x plus a half. So if for any reason you didn't see this as a choice, you could always look for that. Like let's say if it was multiple choice. Most likely though, we're stopping at that first step. All right. Before we look at the last question in the notes today, we got a little rule to think about. The little note here. And normally this is where I'd ask you guys for some numbers. So I'm going to pretend that you've told me some of these numbers. So if I said, let's pick 2 numbers. So if I've got 4 and 7, I'm going to subtract 4 minus 7, and then in the denominator, do the reverse, 7 minus 4. All right, if we do this, 4 minus 7 will give me negative 3. 7 minus 4 would give me positive 3, which when I take the quotient, those will cancel, and I get negative 1. And I could say, okay, let's pick 2 different numbers. So if we pick, 10 and 15, 10 minus 15, 15 minus 10. So if I flip the order, this would give me negative 5. This gives me positive 5. Again, I get that quotient of negative 1. And so what I'm trying to show you here is that no matter what 2 numbers I pick, so let's say we picked like 1 and 8, so if I go 8 minus 1 and 1 minus 8, I would get the same difference. One will come out positive, one will come out negative. And so I always end up with a -1 because in general, if I have something like x minus y divided by y minus x, based on everything we've just seen right here, those two can cancel out. And what we'll be left with is -1. That is going to help us simplify down some of these expressions that wouldn't otherwise look like they could be simplified. All right. So let's try it. And I'll give you a really simple one to see it. If we do 5x minus 10 and then over 2 minus x, and I ask you to factor it, in the numerator, we can take out a GCF and we'd be left with x minus 2. In the denominator, there's nothing much happening here. It's already, in simplest form, basically. So we would just have 2 minus x. All right, here's what I'm talking about. X minus 2 over 2 minus x. I can cancel those based on my little rule here. And I would just leave a -1 in place of one of them. All right, which then means I have 5 times -1, or my answer would be -5 here. I don't want to leave -1 in place of both, because then that -1 would cancel with the other, and I'd just be leaving a 1, and that's not my goal. All right, let's try one last one. So here's our last example in the notes today. X cubed minus 5x squared minus 9x plus 45. All of that. Whew, we're going big here. Over 27 minus x cubed. I mentioned all sorts of factoring back on the last page. Here we've seen GCF. We've seen difference of squares. We did add, multiply. We did slip and slide. Look at the last two we haven't done yet. All right. When we have 4 terms, what should come to mind is that we're doing a little factoring by grouping. So let's take that top factor and let's mess with it. So x cubed minus 5x squared. And then we've got minus 9x plus 45. If I group the first two and group the last two, we take a GCF out. So this leaves me with x squared times x minus 5. Over here, I want the same factor left. So if we take out a -9, we'd be left with x minus 5. And now the common factor between these two expressions would be the x minus 5 itself. And then we're left with x squared minus 9, and then keep going. X minus 5, x plus 3, x minus 3. All right, all of that is the numerator. So let's write that down. X minus 5 times x plus 3 times x minus 3. Right, the denominator, 2 terms that we would typically think difference of squares, but those aren't perfect squares, but they are perfect cubes. So difference of perfect cubes, we would have to take the cube root of each. So the cube root of 27 and the cube root of x cubed gives me 3 and gives me x. So right beneath it, I'm going to bring this down. Since the number leads and then the variable, I'm going to do the same thing in the parentheses. So it's going to go 3 and then minus x into the second parenthesis. The rule is take the first number and square it, so 9. The middle term is the product of the two. The last number is the second part squared. And then because there's only ever one minus sign, this is plus, this is plus. Ooh, that's a lot of factoring. All right, let's finish it. We have an x minus 3 here, and we have a 3 minus x there. There is that rule where when they're the exact opposites around a minus sign, you can cancel and leave -1 in place of one of them. It doesn't matter which. So my final answer, I'm just going to leave that negative kind of hanging out front. It's going to be x minus 5 times x plus 3. And then in the denominator, I have that factor of 9 plus 3x plus x squared. Oh, that was a beast to end on. Nice job. Thanks for watching, guys.